Kia ora whanau. This video is all about calculating probabilities using the standard normal distribution. Well, let's get straight into it. We're going to consider 4 cases. In this video, we will consider case 1 and 2. So you can consider this video as part 1. And in the second video, part 2, we will consider cases 3 and 4. I will be going through this in reasonable detail, so you may wish to skip forward through the parts which you already know. Alright, let's get it on, let's start it. So here's scenario 1. The length of branches from a kahikatea tree plantation is, well, that should be R, but assumed to be normally distributed with a mean of 1.8 meters and a standard deviation of 0.18 meters. Calculate the probability that a randomly selected branch is between 1.8 meters and 2 meters. Very first step, we need to visualize. So let us sketch. We're going to sketch a normal distribution. Sketch is fine, does not have to be accurate. Place on there your central point, 1.8 meters, which is your mean, and your standard deviation of 0.18 meters. Now remember, we need to use the standard normal distribution to help us calculate the probability. So we're actually going to draw 2 diagrams. So firstly, let me mark down 2 meters, because that's important. It's important because we want to select a branch which is between the mean of 1.8 and 2 meters, which is obviously higher than 1.8 or to the right. So in terms of the shaded area, or the part that we want, there it is, in blue for the normal distribution and in orange for the standard normal distribution. However, we need to know what that value is going to be in order for us to then find the probability that we want. So what we're going to do is we're going to use this formula here. Now, it's worthwhile to remember this formula and worthwhile to practice how to use it. So please have a calculator handy, and you may wish to do the calculation as well. So there we go, z equals x minus mean, which is the m there, divided by the standard deviation. Now I've also put in brackets there x next to the 2 meters, because that's the value that we're going to use. We know what the mean is of 1.8, and we know what the standard deviation is of 0.18. So carefully putting that into our calculator there. Those are the values, and what you will get is that answer there. And so on our new diagram, on the standard normal distribution diagram, you can replace our question mark with that number there. Alright, so I know this is a long process, but let us press on. Let's actually find this probability now that we have the z value. So there's our table, there's my little picture there on the top right. Now in terms of how to use this table, let's get straight into it. So we're going to look up 1.11. So we're going to start with 1.1. There's the second one, and there's the third one. So that's 1.111. Reading from left to right on the table there. Okay, so that is the main probability that we're looking for there. 0.3665. However, we need to add that 2 from the differences column onto the end of our probability. So in other words, there's our answer. Now, you may wish to know that the diagram on the top left, in the black there, the shaded black area between 0 and z, is exactly looks pretty similar to what I've done with the orange shaded area. Now, the reason I've done that is because you must remember that the probability that you look up using this table will be between 0 and the number that you specify. Okay, so that's case 1. Let us move on to case number 2. So here we go. The length of branches from a kahikatea tree plantation are again normally distributed with a mean of 1.8 meters and a standard deviation of 0.18 meters. So we've got the same scenario here. This time we are going to calculate the probability that a randomly selected branch is between 1.7 meters and 1.9 meters. And take a moment and try and picture what that looks like. So remember, on the sketch here, I've got my normal distribution on the left and standard normal distribution on the right. So I've plotted my two values here, 1.7 and 1.9. Doesn't have to be accurate, remember, approximate is fine. Now we need to also map that to the standard normal distribution. So there's a shaded area there which we want. And in terms of our standard normal distribution, I'm going to do something a little bit different. This time, with the 1.7, I know it is to the left, so I'm just going to make that piece of the puzzle yellow. Alright, so in terms of that number that corresponds to the 1.7, there's my formula there. There's my x minus m divided by standard deviation, or 1.7 take away 1.8, all divided by 0.18, and my answer I get is negative 0.555. Now don't be scared by that negative, because it's definitely a negative number. As you can see, the mean is 0, so anything to the left of 0 is going to be negative. So that's half of the puzzle. Now remember, there's also the right hand side, so we need to consider the 1.9 meters. So let us press on and have a look at what we get there. Oh look, we get the same value. And if you look at it closely, we have symmetry around the mean. So if we go to our normal distribution diagram on the left, 1.7 meters is the same distance away from the mean as 1.9 meters is from the mean. So you may want to think about that a bit further, but if you're happy with this, the two pieces of yellow and orange to the puzzle, let's press on. Let me just write that down for you. So we're going to look up 0.555 in our normal distribution, standard normal distribution table. There we go, there's our table again, there's my diagram on the top right. Now let's go straight into the crux of this. 0.555. There we go. Now I do realize that you can have more decimals, but this table does decimal places, but this table does not allow for that. So the probability we're concerned with is 0.2088, but considering the differences column, we also need to add 17 onto that. So in terms of our answer there, we're going to get 3005. Now remember, this is only the orange part. We also have the yellow part to consider. Now remember, because they're both 0.555, it doesn't matter about the positive and negative. What matters is that both of the pieces to the puzzle, the yellow and the orange, are exactly the same size. So if that's the case, then all we need to do is add a second probability, which is of the same value or the same size. So in terms of our final answer, 6010. That is the end of part 1 of this video. Part 2 will consider the other two cases. Thanks for watching.